Starting in 3.
Good morning, good afternoon, good evening, wherever you are in the world. Thank you for joining us today. My name is Steve Robinson. I am one of the business development guys at Galarath. I'm based in the UK, so too is my colleague Keith Garland, who is our training and support manager, and he's also on the line, and Keith's going to be the one that's walking you through this today. The purpose of the next 15-20 minutes is to introduce a capability to you, which we have developed specifically for design to cost activities, which links step files from any CAD system through our SEER 3D interface in with our manufacturing process estimation tool, SEER for manufacturing, and is able to create very quickly and very robustly estimates for composites, for machining, for additive manufacturing, and in the case of the next 15-20 minutes, sheet metal fabrication as well. What we're going to do is provide you with an overview. We're going to touch on a lot of the capabilities that are inherent within the tools. We're not going to go into a lot of detail. More detail will follow in more of these recordings as we go along over the next weeks and months for you to view and review and question. If you do have any questions, mine and Keith's details are on the screen. Please feel free to reach out to us. We will be more than happy to help or point you in the direction of somebody more appropriate within our organization to answer your questions. So without further ado, I will hand over to Keith to actually go through the material for you. Keith, it's over to you, sir.
Thank you, Steve. So hello, everybody. Today, like Steve said, we're going to look at SEER 3D and its sheet metal capability. So in front of you, you see the SEER 3D GUI. It's the same GUI, whether it be machining, additive, composites, or sheet metal. They're just individual processes licensed within the front end to allow you to access the different estimating capability. So all I've done so far is I've imported a sheet metal sample. That brings it up onto the screen. We then go to the general settings. And from here, this is where we can basically select the alternative processes that we have. So today, machining, additive, composite, sheet metal, with more processes in the development pipeline, including assemblies and some of the other processes that are important to our customer base. So the model itself drives from what we call manufacturing environments. And manufacturing environments are here. They can be set up by ourselves, by yourselves. We train you how to build them so that you can build into the model your limitations, your constraints, your processes, your items that you can build into the estimating so that you can capture the things that you do best, your inefficiencies, your efficiencies, your rules, your assumptions, to introduce consistency, repeatability, and overall speed into the estimating arena. So these are just some sample ones that are delivered with the model. So I'll just select, I'll call it a clip or a cleat, and we'll make 100 of them. So the first thing you'll see is the set of amortization jumped to 10. That's because in the rules file, it says that my amortization will be 10% of the production quantity. It doesn't have to be that. You can change that now. I can change that to 20, 50, 100, whatever you want it to be. Or you can change the environment to have one that says I'm always 15%, for example. We select the materials. Now the material list is the same list that resides in SEER for manufacturing. And because it's SEER for manufacturing, you have the ability to add all your own materials to the system so that you can reflect your own buying powers, you can reflect your own material specifications that you work with on a regular basis. So I'll say it's aluminium alloys. Shape complexity is rated by the model based upon, again, within the rules file, it's going to count things like the bends and contours and different things that will add up to rank its complexity. We can show the flattened view, so we can make sure we have the right size bounding box to get this into it. If you have particular grain flow options, you can user defined, and you can select one of the other criteria here to align the material to geometry, or however you wish to do it. So it's brought in the geometric sizes, the part shape, and then we can turn on and off the bounding box. We then select the process from the list. Now, the default from this environment was the break form, but we can change that to one of the other ones if we wish. So I want to leave it at break form, so I just click out of there. This is other form types. So if you wanted to add, I don't know, a guillotine up, or you wanted to add something else, you can do so, but I don't. I want to remove it. So I'm just going to, how do I select it and remove it? So you can add multiple press operations if you wish to make sure that you cover all of the shapes, all of the contours, whether you draw rubber, then break form, whatever you need to do within the process itself. So this is the first screen, and we've set the model up now. We're sheet metal, we've used an environment, told it the quantities, the material, complexity, part shapes and sizes, and our first bending operation, or the main bending operation in this case, that we're going to proceed with. Into the process operation tab at the top, you can see now the operational sequence that the model has selected to cover this part. Now, I don't want that one, but I am going to do laser beam cutting. So I'm going to cut out the periphery using laser beam cutting. We're then going to step forward, or step back actually, because on this one, this is where we set the break forming operation. And then to finish it down here, we're going to do a little bit of truing up with a bit of hand hammering maybe. We're going to anodize the part, we're going to epoxy prime and polyurethane paint. And if there's any heat treatment ops, annealing, age hardening, you can add them as well. But I'll exclude that in this case. And again, we can include or exclude tool fabrication and design, which would bring in the associated tooling that had been selected previously within the environment folder. In that folder is an Excel workbook with lots of parameters, things where you can set the defaults, bounding box excesses, and the process rules associated with the part family that you're trying to create. Within there, you can also select the tooling list. So what tools do I need? Do I need machine control media? Do I need bolster blocks? Whatever you need to produce a part for the part family that you wish to create. The model then steps on to the features. So what it's done is it's gone around and it's counted every feature, and then based upon that feature count, it works out the complexity. And so I'm showing the different features here. So this is compound bends, and so on and so forth. So it has 14 features it's discovered in its analysis. And if you think it's missed something, by all means, you can say, I don't want to put the holes in, for example. So you could remove the holes at this stage, or include them if you don't want them put in as part of this process operation. I'm going to put them back. I think it was 6, and we're ready to go. So the estimate will now be completed by SEER. It's going to take all the geometric features, functions, faces, etc., peripheries for the laser cutting operations, the bends for the bending operations, and produce us an estimate in our core costing engine, which is SEER for manufacturing. Click on the estimate button. Hopefully that's worked. It's gone grey, it hasn't come back. So that's going away now. Hopefully it's creating a SEER for manufacturing estimate. Here we go. And it's brought in an aero sheet metal work element and a fabrication work element for the preform laser cutting operation. You may wish to put that in the other order, so it's in the sequence that it would appear, but that's entirely up to you. The main thing is all the ops are covered. So it's brought in our costs and time. We have detailed estimates here. So I'll just introduce you to SEER for manufacturing. This is the tool that Gallerith has developed over many years. It is our 2D costing solution across a wide range of processes. It covers a multitude from machining to harnesses. And let me just show you the extent of the processes that it will cover. So this is the dialog box where we select the processes. Like I say, the machining, and within machining, we've got the drilling, the milling, the turning, the grinding, the honing, the lapping, all of the main machining processes. Fabrication is, again, sheet metal operations, etc. The arrow down here is telling us that the processes here were developed by the partners of the Joint Strike Fighter, the F-35 Lightning. Their standards were pulled together and embedded into SEER MFG, and this was the resultant processes that were embedded. Fit up, drill and fasten are for aircraft assemblies, composites, hand layout, toe placement, and that's also covered within the 3D models. Curing and trimming works together with the composite for the curing of the composites, paste bonding, 3D reinforcement, more sheet metal operation, which is this work element called 112 sheet metal, superplastic forming, diffusion, bonding, purchase parts, detailed composites, additive manufacture, tube weld, and processing. And at the top, we got harnesses, we got assemblies, we got moldings, castings, forgings, isostatic presses, injection molding, PCBs, PCBAs, finish and heat treat for your treatments, your painting, your sanding, honing, and things such as that. So all of these are built in here. They work in conjunction with knowledge bases where you can set them up to preset the model up to help you speed up your estimation process to introduce consistency. I'll cancel out of that, we don't need it. So back to SEER itself, our 4-pane configuration. We have our work elements. This is the building blocks to transform our nice piece of flat aluminium alloy into that wonderful finished component. And for every line item here, we have a set of process-specific parameters. We have tooling tabs, we have inspection, rework, part mark and package are all the same. So depending upon the process that we have, these will vary. And coming back to this one, the general tab is set it up. This is our 100 and batches of 10. Labor rates have come in. Looking at the inputs here, product classification, it was obviously done for an aircraft part. So if we look at the help, it will tell you that very high items designed for high-end reliability applications, aircraft, military, space, etc. That could be detuned. We could turn it down to nominal for other industries, for commercial, consumer, vehicles, and the like. So the model is very versatile in that respect. So capabilities of the people, and you'll see that within SEER we have this 3-point capability where we put a least, a likely, and a most. So if I come back to this one, we can say that basically the most likely we have very high, some highly experienced people. Some are going to be superstars, some may not be so good. They may be semi-skilled, they may be apprentices, but within the average manufacturing shop, you will get a range of capabilities. Not everybody's wonderful, not everybody's poor, but you can capture that, and it will take a per mean average, 4 of the likely, 1 of the least, 1 of the most, and that also enables you to do Monte Carlo risk analysis within SEER for manufacturing. So coming back to our estimate, we've introduced SEER for manufacturing. These are the building blocks. Each one of these little icons represent a different process. So our preform is using fabrication as the process step. And if you come to the process specific, we'll see that this is where we've done the laser cutting. So yes, the laser cutting is calculated the periphery, the length of the cut, shape complexity has come in from the model, and so on. So that's generating us a laser cost. We then go into the sheet metal, which is using aero sheet metal, and you'll see the process steps here are yes, no's, so there's no preform operations. Yes, we are going to break form it. After form operations are going to be none, and then we've got our drop hammer, or hand hammer, sorry, and then we go into our part finishing operations, our anodizing, our epoxy priming, and polyurethane paint. So that's all and done. And that's just a simple method of yes, no, because the aero sheet metal was founded on many hundreds of components. I think it was into the millions of parts that were analyzed such that you can use this yes, no to develop very accurate SEERs. So you're not worried about the length of different things or the number of bends. Just tell it what the process is and it will give you estimates based upon the part area, part size, part thickness, material type, etc. So this is the estimate as it comes out. The tooling, we said yes. So it's come in with a brake die, handling fixture, inspection and rework comes in automatically. In process inspection is the operator checking his job. In process rework finds he needs to do a little bit more hand hammering to put it right. QA inspection is a formal inspection op. Rework is a formal rejection by the inspectors where job cards has to be raised to do some additional work. Many of you will say zero these out. Some of you will say this needs to be 10% or whatever you want. Part mark and packaging, so you can wrap it, you can write tags, you can do a variety. These are growing lists, so you can do pencils and labels and fabrication of nameplates, etc. So we'll cancel that. So coming back to our process steps, so we have our detailed analysis here, we have our time per unit, our setup time, our direct time, our inspection and rework, our material cost, tooling cost, all coming together to estimate this one part. And we have the quick estimate, and again with the quick estimate we can set a reference, set it on this one maybe, yeah, this one, set a reference, click on OK, and we come to the process specific, and maybe we'll change a material. What if we make this out of, I don't know, stainless steel? Click on OK, and you'll see the instant impact. The weight changes, the minutes change, the material cost will change, and all of these have changed as a function of the material change. So you can do these very quick what ifs. You could change the process, you can change the material, you can change the capabilities. So we can say, but what if we put everybody as superstars, put them onto here, click that to the top. It's going to make it less of an impact. So anyway, it wasn't a good decision. Right click, revert to reference, puts everything back to how it was. We can go back, we can clear the reference. We've done a bit of a trade. We can now explain to our superiors why we've gone with the process we've selected, why we've gone with the laser over the rotor, the brake press over the draw rubber, and so on and so forth. So we've done our task, we've got our estimate, we can report it. If we come to the sheet metal here, we have the aero detail report, where we'll go into some detail showing you the process steps, setup times, direct times, T1 minutes. So again, don't forget that within SEER, we can quite quickly and quite easily go into options, set project parameters. We can change the currency to euros. We can change it to US dollars. And everything will update itself automatically. We can work on multiple currencies. We can do learning curves. We can do the Wright and the Crawford cumulative average in unit. We can work in imperial or metric, base years, and all the standard things you would expect from a thorough estimating tool such as SEER. So that is SEER for manufacturing. Just a quick recap. We import the part, we go to the general settings, we select the process we wish to use, we're going to select the environment that we wish to use, we tell it how many we're going to make, we can alter and adjust the default setup quantity, ensure the material's correct, look at the bounding box, make sure we're happy with that, select the process operation for the bending ops, come to the process itself, ensure that we're going to cut it out with the process that we're happy with, which we've selected laser beam, a little bit of truing up, we're anodizing, epoxy priming, and so on. Features themselves are just a counting operation where we can either increase or decrease it. We can identify them or not, and then estimate. And that's the full process that the model will go through. A thing to mention is the same for all of the 3D solutions. You can batch run the model, so you can have an interface where you point SEER for sheet metal, SEER for machining, 3D options to a folder, tell it what environment you wish to use, what the quantities are, and it will run that batch. It will create an individual estimate for you in that folder, and it will then finally merge all of the estimates into a single file for reporting. So if you have large numbers of particular parts, that's a very, very advanced feature which will allow you to do large quantities while you go off and do other tasks, or you go home and leave it running overnight. So thank you for your time. That is SEER 3D for sheet metal. I'll pass you back to Steve, and thank you very much for your time.
Thank you, Keith. Hopefully that's given people a feel and a flavour for the capabilities that we were talking about, not just with taking step files for fabricated components and feeding them very quickly into SEER for manufacturing, but also a bit more of an overview of SEER for manufacturing itself. As we said at the beginning, if you have any questions, Keith's details and my details are on the screen as we speak. Please feel free to drop us a line. If we can answer it, we will. If we can't, we will find somebody within the organization better placed to do so, and we will pass that on and get answers to all of your questions. There will be more in these series of recordings, in these overviews that will go into some specifics. For instance, the creation of environments and those rules files that Keith was talking about. But for now, thank you for your time, and let us know if you have any questions. Thank you very much.
Thank you.